And last but not least, molecular geometries. We learned these as ways to make sure that the molecules we're drawing are the right shape. We were just sort of throwing them down, plus sign, straight line, whatever, when we first learned Lewis structures, and you guys were like, where do these electrons go? This is the answer to where. I wrote down in this review packet the numbers you need of bonds and dots on your central atom for these molecular geometries. Linear, 2 lines, 2 shared domains. Remember, a multiple bond counts once, so 2 shared, 0 unshared for linear. 3 and 0 for trigonal planar. Planar is flat. Bent, there's the 2 and 1 bent. I wouldn't worry much about this. I don't like that bent. I like the 2 and 2 bent. Tetrahedral, 4 and 0. Trigonal pyramidal. It's one of the ones with dots in the middle. Trigonal pyramidal and bent. Both are that shape because of their unshared pairs. Trigonal bipyramidal with 5 and 0, and octahedral 6 and 0. You can use this and follow along on this. I'm doing these. Again, if you want to pause and do them or stop every one, whatever. I'm counting the valence electrons quickly, so get in touch with me if you have any questions about how I'm getting the valence electrons count. Remember, it's right from your periodic table. Groups 1 and 2 have that many, and 13 through 18 ignore the 1. So, CH4, 4 from carbon, 1 each from the hydrogen, for 8 total. Carbon in the middle. I'm going to try to put them sort of here-ish, or even better, now that we've seen that 8, I may erase some in there. But carbon's in the middle, and it gets hydrogens. Now, normally we would draw it sort of like the plus sign Lewis structure, and that's fine. That used my 8 electrons. Each bond is 2 electrons. 2 times 4 is 8. So I think about it. On my carbon, I have 4 shared pairs and 0 unshared. 4 and 0 makes a shape called tetrahedral. Tetrahedral like a little lunar lander. There you go. Redrawn in the correct shape. OF2. I'm going to put the count above, so I've got a little more room. 6 from oxygen, because it's in group 16. Fluorine is in group 17, but I have 2 of them. So OF2 has 20 electrons total. Let's put oxygen in the middle, and fluorine's out to the side. I know what fluorine does. 1 bond, 6 dots. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There's my 20 electrons giving everybody 8. But I look at my central atom, my oxygen. 2 shared pairs, each of my bonds to fluorine, and 2 unshared pairs with my dots on oxygen. So this molecule would better be drawn as bent, kind of like the bottom of the tetrahedral molecule. So 2 shared, 2 unshared, bent. PCl3, 5 from phosphorus, plus 3 from 3 chlorines, 7 each, for 26 electrons. 26 gives me, and I'm probably going to redraw this one, it gives me phosphorus with 3 chlorines. I used 6 electrons there, leaving me 20. Each chlorine's going to want 6 dots, because it's in group 17, that's what it does. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I have 2 left. Chlorine's good. It must be that phosphorus that needs them. 2, 4, 6, 8. That middle atom's all jammed up. I'm going to need to redraw, but how? If I check out my central atom, what's got 3 shared and 1 unshared pair? It looks like trigonal pyramidal. So let's make it a pyramid. Let's give it this little flat top and put my chlorines down. Ta-da, a pyramid. trigonal pyramidal with 3 shared, 1 unshared. CO2, moving right along. 4 from carbon. Each oxygen 6, so 2 times 6 is 12. 12 plus 4 is 16 electrons. There you go. So, carbon in the middle, oxygen on each side. That is not going to work. That is not going to work because that's carbon with only 2 bonds. It's going to need a ton of dots. We're not giving it dots. We can multiple bond, though. We can bond carbon to oxygen more than once, but it can't do 3 times. It can only do twice. There's hope. Carbon dioxide has a double-double bond. That gives carbon its 4 bonds. It doesn't overdo oxygen. Oxygen likes 2 bonds and 4 dots. So out of that 16 electrons, I've used 8, and I can use 8 more. 2, 4, 6, 8. I'm not redrawing this one. This one says really nicely that central atom, 2 shared domains, because we count a double bond once. 2 shared domains, no unshared. We've got linear. I guess I can go back and write tetrahedral there, and bent. And this one is, I'll take out my electron count, trig, and one's pyramidal. At least they're abbreviations. BH3, easy electron count, like super easy electron count. Boron gives me 3, it's in group 13. Each hydrogen gives me 1 for 6. That's about as easy as you can get. Remember boron, the 3-legged dinosaur? Boron says only make 3 bonds. So I put 3 to the hydrogen, I spread them out, and I think I'm done. I used my 6 electrons that quickly, and 3 shared, no unshared. There's no dots on boron there. This one is going to be trigonal planar, flat triangle, because it is a flat triangle. H2S, it's going to look like H2O. I always do. Water. Sulfur and oxygen are in the same group, so they'll look alike. 2 from hydrogen and 6 from sulfur gives me 8. I think I know what's going to happen here. If I put sulfur in the middle and 2 hydrogens on it, I'm already almost out of electrons. Sulfur needs more, hydrogen sure doesn't. I have 4 electrons to use. I'm going to give them to sulfur. I repeated this one. Sulfur has 2 bonds, 2 pairs of dots, so it is better drawn as bent. Below this are some practices for you. What I didn't put on here, and I don't know if I've put them in your practices or not, are examples of trigonal bipyramidal molecules and octahedral molecules. We looked at those in the last lecture. PF5, PCl5, anything with 5 is trigonal bipyramidal. SF6 is my octahedral molecule. That's my go-to for octahedral. 6 bonds on sulfur, fill it in with fluorine. So we reviewed the types that are fair game. I don't think you're going to see the 2 and 1 bent, but you're going to see these. So with that, you should be good to go. Do your practices. I'm going to draw them and post a picture of them for you tomorrow, and you'll be able to see those. Check them. Let me know. We've got one more review to do, one more big unit, 3 lectures on equations and a quick overview of stoichiometry. I think you're going to be happy with how few big ideas there are in that. When we got down to it, it wasn't the toughest stuff that I want you to know. So you should be happy with that one. No big review of gas laws. We're almost there for the final. Have a great day.